All right, so just wanted to mention a few tools to look at your resource utilization from the command line in a Linux, Unix environment. So let's look at uptime. Uptime tells us not only how long the machine has been running, but also um, how many users are logged in and our load average. So the load is, a load, when you look at load, um, if I start to get a little concerned anytime the load is above 1, but that's just me thinking in the past. Anytime you have more than one processor, you should be able to handle more than a load of 1. A load of 1 it's kind of, I guess the easiest rule of thumb is if your load integer here is higher than the number of processors you have, then you should be concerned. The machine can certainly switch tasks and handle more than uh, double or even sometimes triple the number of load points versus your CPUs, but it's just an obvious sign that the system is starting to struggle. There's some sort of blocking going on. So how many CPUs do I have? I could cat proc CPU info, and I don't have to scroll up to see that I have 4 CPUs. The processor IDs start with 0, so I have this number 3 lets me know that I have 0, 1, 2, 3, 4 processors. So a load of 4 is not terrible on this machine. So how much? Well, first of all, let's quickly look at how that might be. Why might I be so high? So I'm going to look at a tool called Top. I see that Chrome is eating up most of the CPU. There's this other process, Knuckle Helper. I think this is related to Chrome. So basically, Chrome and its buddies are eating up all of my CPU. I oftentimes use a lot of tabs and things like Gmail and some of those really interactive sites do use a lot of RAM. Also, your screen window, your fancy window system, Unity or things like that will eat a lot of RAM and processor. So here I've identified the things I could kill with a K. Any one of these process IDs or PIDs, but I'm not going to do that. I'm gonna go close some tabs after this video. But that's how I know where I'm at. So, by the way, the load average, the 2 is the 1 minute load. This is a 5 minute kind of average, and the 15 minute load average. And it doesn't tie strictly against CPU usage. It also takes into account memory pressure and disk speed. So if you look at all these things, it kind of is a combination of, well, this shows you what it's waiting on. So 29% on user processes, 5.7 on system processes. I believe this is NICE processes. I forget what this is. I believe this is waiting on disk. Anyways, let's see. Quit. I'm going to Control C to get out of this screen. One more thing. If you want to sort by memory, usually you can do Shift M, and it'll begin to sort by memory usage. So tons of different Chrome tabs individually with their own processes eating up my memory. If I want to sort by CPU, again, Shift P. MP, and there's other things as well. With the little C, I can show the longer command that's running. All right, another tool that once you start looking at this, you might want to go search for maybe what is the parent of this process ID 32597, for example. You could do like PS-EF just to show you that output. It shows you the user ID, the PID, and the parent PID of the commands, and how much time. This is not like when it started, this is just CPU time, clock cycles that it has taken. I'm going to grab my PID that I was looking for. Oh, look. So its parent is 2179, and I could go up through the tree. There's also a command called pstree-p. So this shows you your processes in a tree format, like sudo's running pogo plug fs with 3 sub-processes and whatnot. So you can kind of see when I kill this process, I'm going to also likely kill or orphan these other processes. They might go stupid without the parent, or they might just cleanly die also. All right, so look, I'm kind of getting long-winded here. Another command is free. I'm going to do the -M flag so that I can show it in megabytes. So what I can see here is that I have 6 gig of RAM on my desktop. It says that I'm using almost all of it, which typically you want to use that RAM. You bought it to use it, so use it up. But what you really you hope that it's doing is having a healthy usage, not an anemic usage of the RAM. So this shows me that I have some buffers and some cache. In other words, some files that I've opened or some things that are going on that I can quickly refer back to. I guess that's a little bit towards the most desirable use of the RAM, is to buffer and cache things so you don't have to go fetch them a bunch of times. And what this shows, this second column, is how much kind of usable RAM is there to where new programs could start or not. Yeah, this is going to show you how many new programs could start. Like this is if you were to go and spend all of your buffer and cache and clear all that out of the way, this number here is kind of how much you have left over. In this one, how much you're using. Now swap, I am concerned anytime I see swap usage above 0. That means that I ran out of RAM at some point and some processes started to use that RAM, and so anytime the program that put data into this space here in this swap space is going to run slower, because what swap is it goes out to a spinning magnetic or nowadays SSD disk, which is still not as fast as RAM by a long shot. Means that any of those processors are going to be slow. Now I don't know of an easy way to figure out which programs are swapping. Somebody could probably tell me, and I'd be a happier person to know. But what I usually do is just see some of the big processes using RAM, and I start, closing tabs or killing those processes or trying to do something to get that back to zero. Once you close the process that is using that RAM, it'll start to go down. But once it's not like you can just start closing processes and it's going to take it first out of here. It's wherever the processes had it used, that's where it's going to start, regaining your RAM back, or recapturing it. It might be from this number, you might start seeing this number drop, or this one, depending on just luck of the draw. All right. As far as usage, it will try to use this before it uses this, but yeah. Now, free, I've talked about that. Now, free. How about VM stat? So again, kind of shows you some of the other numbers that we've already seen. But anytime you start seeing wait state, you're waiting on something, whether it be network or disk, and anything above 0 here is telling you that at some point your machine was starting to wait on stuff. All right. There's other commands like iostat. You may have to install a package or two here. This is kind of a I don't think you're going to see really long averages with these, even though they call themselves averages. But this shows you your current per second read bandwidth. And now that you're thoroughly bored, I'm sure there's some other things I mentioned to share, but I'll call that good. You can always ask me more about it. Thanks for listening.